Let's now look at a few exam questions. The idea here is that you obviously practice and that you feel comfortable looking at these questions, applying the things that you learned in the previous lesson, and eventually realize that this is not complicated at all. This one is taken from paper 2, summer 2008. And the question is this one, question 4. It says, the polynomial 2x cubed plus 7x squared plus ax plus b, where a and b are constants, is denoted by px. It is given that x plus 1 is a factor of px, and that when px is divided by x plus 2, the remainder is 5. Find the values of a and b. These two things over here should ring two different bells. X plus 1 is a factor, and x plus 2 is a divisor. When x plus 2 is a divisor, the remainder is 5. So this is asking you literally to use the factor theorem on this first piece of information and the remainder theorem on this second piece of information. And how do you do that mathematically? The factor theorem says that substituting x by minus 1 will make this polynomial to be 0, the whole thing to be 0. So p of minus 1 is 0. On the other hand, the remainder theorem tells you that if you now substitute x by minus 2 on the polynomial, you'll get the remainder, which has the value 5. In other words, p of minus 2 equals 5. Now you plug this in to create some simultaneous equations, and I take that at this moment you all know how to solve simultaneous equations, all right? And you eventually will end up with the values of a equals 2 and b equals minus 3. Not complicated at all, right? Let's look at another example. This is spring 2014 question paper 21. And the question is this one, question 3 over here. I'll put it bigger. Find a quotient when 6x to the power of 4 minus 6x cubed minus 26x squared plus 4x plus 15 is divided by x squared minus 4 and confirm that the remainder is 7. You then are asked to hence, so with whatever information you get from part 1, solve the equation 6x to the power of 4 minus 6 cubed minus 26x squared plus 4x plus 8 equals 0. I should say at this moment or remind you that the idea of these videos is not for you to look at a question and look at the solution without trying yourself the question. So I invite you to pause the video, either look at the question over here or find it yourself and try to solve the question and then continue the video to see if you got it right. So how to solve this? This is a fancy way of asking you to just divide this by this and confirm that the remainder is 7. So basically, that's all you have to do. You divide this polynomial by x minus 4, following the rules that I told you before. So you look just at the terms with the highest power. So 6x to the power of 4 on the dividend and x squared on the divisor. You divide this by this, and you get, and the result is obviously 6x squared. You should write it right on top of the column with the x squares, all right? So 6x squared, now that you have written it, you multiply it by the whole thing, by the divisor, and you get this, 6x to the power of 4 minus 24x squared, right? 6 times 4. 6 times minus 4 is minus 24, x squared, that's what you write there. Notice that there is one term with no value, that is the x to the power of 3, x cubed. I wrote it anyway, just to ensure that I don't mess up with the calculations. Now it's time to subtract. This is obviously 0, that's the main point of doing what we did before. Minus x cubed, you just write it over there, and minus 26x squared minus 24, that's plus. you'll have the result minus 2x squared. You now have to bring the 4x down and then repeat. So you now divide minus x cubed by x squared and you get minus x. Minus x times x cubed is minus x squared. Minus x times minus 4 is minus x times minus 4 is plus 4x. So you write these two on the corresponding places. Again, this one under the x's to the power of 1. So you leave here 0x squared. You subtract. This is 0. This is going to be minus x squared. This is going to be 0 again. Now you bring this 15 down. Here you have minus x squared, which is the same order of that one, so you can still divide. Minus 2x squared divided by x squared is just minus 2. Multiply again, and this is what you'll get. Subtract, and you have the 7 there. You get the remainder as you, the quotient as you were asked. Find a quotient, so you found it. And you have proven, while doing so, that the remainder is 7. Imagine, just for a bit, that the question didn't ask you for the quotient, but just to prove that the remainder is 7. In that case, it will be even simpler. If you knew that the remainder is 7, so you know that when you divide x squared minus 4 from the equation, the resulting remainder needs to be 7. So this means what? This means that the outcome of equaling this to 0, which is, by the way, minus 2 and 2, if you substitute minus 2 or 2 into this equation, you will get 7. That's what the remainder theorem says. So all you have to do is to plug in these values, minus 2 into the polynomial and 2 into the polynomial, do the necessary working out, and eventually you'll get 7 on both. All right? So by using the remainder theorem, you would prove that the remainder is 7 just by equaling the divisor to 0, getting the corresponding values of x, and plugging them in on the polynomial. You have a second part of the question, if I'm not mistaken. Hence, solve the equation 6x to the power of 4 minus 3x cubed plus 26x squared plus 4x plus 8 equals 0. Pay attention to this, because this polynomial is not that one. It's very close to it, but it's not. This is plus 15, and this is plus 8. So what's going on over here? Well, if you pay attention, you know that if you subtract 7 to 15, you get 8, right? So what did you get with the remainder over there? You know that the whole polynomial, the dividend, is equal to the divisor times the quotient plus the remainder, right? If you now send this 7 to this side, you get what you want. You'll have the polynomial over there. And this equals to the quotient times the divisor, right? So what does this mean? This means that this equals to 0 is just this bit equal to 0, which is much simpler because it's already in factor form. So you just have to equal to 0 this bit and that bit over there, and solve for each one. Actually, this one you already know. We did it a little while before. The result of this is minus 2 and 2. All you have to do is to solve this one, and by using the quadratic formula or whatever method you want, we end up with the results minus 1/2 and 2/3. So the total number of answers that you have is 4. Well, it's a quartic, so that's the maximum number of answers you can have for equaling it to 0. And they are minus 2, minus 1/2, 2/3, and 2. Let's look at one more exam question. This one is from spring 2015, question paper 21. And the question itself is this one, question 4. Again, look it up or look here at the board. stop the video, try to solve it yourself. The question asks, the polynomial fx and g of x are defined by f of x is x cubed plus ax squared plus b, and g of x is x cubed plus b of x squared minus a. So they are related by the coefficients of different terms, which are by a and b, that are constants. It is given that x plus 2 is a factor of f of x, and it is also given that when gx is divided by x plus 1, the remainder is minus 18. So again, it's the same thing as the first question. This is asking you to use the factor theorem on f of x. This is asking you to use the remainder theorem on g of x. So you know that substituting x by minus 2 over here will zero f of x. So f of minus 2 is 0. And this means that if you substitute x by minus 1 over here, you'll get the remainder, which is minus 18. So f of minus 1 equals minus 18, right? Find the values of a and b. This is what I just said. So you just plug in minus 2 over here and minus 1 over there. Equal this one to 0, equal that one to minus 18, solve the corresponding simultaneous equations, and you'll get the values of a and b, a being equal to 5 and b being equal to minus 12. There's another question over here. When a and b have these values, the ones we just got, find the greatest possible value of g of x minus f of x as x varies. So the difference of those two. So this is stuff from last year, actually. You just get the difference, and this is what you get. It's a quadratic. The value of the coefficient of x squared is a negative 1, so it's an upside down quadratic. You want, let me see again, you want what? The greatest possible value. So what is the greatest possible value of an inverted parabola? It's its vertex, right? Where the maximum possible value is the y-coordinate of the vertex, and the vertex is where? If you look over here, the vertex is obviously on point 0, 7. So the greatest possible value of the difference is y equals 7.